Hello and welcome back to my channel. But as you know, this is all about community medicine. If you're new to this channel, please do subscribe. It means a lot to my growing fraternity. But today I'll be taking up something very interesting. That is emerging, re-emerging infections, early identification and control of new infections. We'll take it up in two parts. And let's begin the first one. Well, to begin with, I would like to quote a very famous bacteriologist, Hans Jenser. Hans Jenser had very interesting observation way back in 1935. In his book, he has mentioned infectious disease, one of the few adventures which are genuine and left in the world. And regarding the infectious agents, Hans has a very important observation that even in normal times, they prey on the weak and the very young and the very old, living along with us in mysterious obscurity, waiting for opportunities. He couldn't have better painted the scenario regarding emerging and re-emerging infections. And his words amazingly remains ever so relevant even today. And despite the remarkable advances in medical science and the treatment during the 20th century, infectious disease remains the leading cause of death worldwide. Emergence of new infections, re-emergence of diseases that had once been controlled, and the persistence of intractable infectious diseases. The scenario continues. During the last 20 years, that is 13 new infectious diseases have emerged. And these diseases are the leading cause of death worldwide, claiming at least 17 million lives. And that is massive. If you look at this map of global emergence of emerging and re-emerging infectious diseases, you will find a globe is almost speckled with blue and red dots. The blue ones are the re-emerging or resurging infections, and the red ones are the newly emerging diseases. And each of this continent is facing a set of diseases, and some of these diseases are having globally spreading their claws. Even if we look at our own country map, we'll see the same thing, that there has been several instances of emerging and re-emerging diseases over the period, be it plague, be it Nipah, be it Chandipura disease, and that too has been widespread throughout the country. And if you look at the COVID scenario presently, the spread across the globe is so massive. This pandemic almost seems to have smeared its existence all over the globe. Now, what is the emerging infectious disease? Emerging infectious diseases are those which are either outbreaks of previously unknown diseases or known diseases that are rapidly increasing in incidence or geographic range in the last 2 decades, or persistence of infectious diseases that cannot be controlled. So as you can see here, influenza, the Marburg hemorrhagic disease, Ebola, AIDS, Nipah, hepatitis C, SARS, the avian influenza, MERS-CoV-2, Zika, COVID-19, all have almost back to back been bombarding our globe. Some had higher intensity, some had little lower intensity, but persistently. And this is not just the exhaustive list. There's far more to this picture in the frame. Now let's understand what are the re-emerging diseases. Re-emerging diseases are diseases that reappear after they have been on significant decline. And re-emergence may happen because of a breakdown in the public health measures that are unable to control the diseases, or they may be due to appearance of newer strains of the disease-causing microorganisms. Even in this circumstance, you can see that there are several re-emerging diseases, be it schistosomiasis, yellow fever, dengue, meningitis, rabies, polio, malaria, tuberculosis, cholera. Almost the list seems to be endless. Here in this context, I would like to quote Cross, who very interestingly has mentioned, excuse me, microbes and vectors swim in the evolutionary stream, and they swim faster than we do. The bacteria reproduce every 30 minutes. For them, a millennium is compressed into a fortnight. And they are fleet of foot, and the pace of our research must keep up with them, or they will overtake us. The microbes were here on Earth 2 billion years before humans arrived, learning every trick for survival. And it is likely that they will be here 2 billion after we depart. How true. It is very evident, and as we will discuss further, we'll understand how these microbes have been almost outwitting us. But the question remains, is it just about a microbe? Is just the presence of a microbe that is sufficient to cause this resurgence or the emergence? Well, it is much more than a microbe. It involves a classical epidemiological triad of the agent, host, and environmental interaction. The environment has undergone several changes in the form of urbanization, deliberate deforestation by the humans, leading to climatic changes and catastrophic events. On the human front, there's been changes in the nutrition, increased travel and tourism, globalization has been on the rise, and increasing instances of immune suppression. And let's have a look at the picture of the agent. They also have undergone genetic changes, as we were discussing earlier, that they have developed that survival trick, that they know how to survive in spite of the odds. They have learned to develop resistance against insecticides over the generations, developed resistance towards antibiotics, and all these have worked in tandem to produce the re-emerging and emerging diseases that our population is facing every day. Let's first understand the effect of the environment. It is seen that climatic changes cause shift in the ecological niche, a range of diseases. And the long-term effects of global warming cause the novel diseases to appear in places where they had never been happening. Coming to understand further about the environment, it's also about the unplanned and underplanned urbanization and the industrialization that has been almost merciless towards the environment that it was a part of. The rapid population growth, almost a boom, led to overcrowding and poor sanitation. And all these had a very bad backup because the public health infrastructure was unable to cope up with this huge population boom and the resulting surge of diseases. As for the host factors, the unsafe sexual practices led to HIV, syphilis, gonorrhea. Changes in agriculture and food production patterns lead to foodborne infections like E. coli. Increased international travel and outdoor activities lead to diseases like influenza, COVID-19, and many more. So the changes in the population density, the human movements, and the environment all interacted to create ecological niches that were more favorable towards the growth of microbiological or viral adaptation. Understanding the agent, the evolution of pathogenic infectious agents were in terms of increased survival skills. They were developing resistance to drugs, resistance of vectors to pesticides. Initially, when the vectors were exposed to this pesticide, we were getting very good results. The diseases were going down. The killing power of the insecticides or pesticides were high. But over the generation, these vectors underwent a lot of changes. And they developed the resistant power. And if you see the picture in the slide, you'll see very less percentage were being susceptible to these pesticides. So if we try to understand the transmission, more than 2/3 of these emerging infections were originating from animals, the wild and domestic. That is, zoonosis were the major reasons of emergence. The emerging influenza infections in humans associated with geese, chicken, pigs, that's the domestic ones. And since they were causing, deforestation, cutting down on the forests, leading to climatic changes, the wild animals being dislodged from their natural habitats, they were leading to, resurge of diseases like Lassa fever. And because the humans were, displacing the wild animals from their habitat, they were encroaching into their habitat and coming closer to the wild animal reservoir or vectors. And these were leading to diseases like yellow fever and malaria re-emerging. If you look at this graph, then we will see there are 3 types of colored curves. The pink area under the first curve is of the wild animal population. The sea green gray color curve is of the domestic animal population, and the red one signifies the human population. So it is that the disease like these, the novel diseases, they are starting in the wild animals. From this wild animal pool, these are getting spilled over into the domestic animal pool. And from those human population who are encroaching into the wild animal niche, they are getting exposed to the wild animals directly, and there also there is being a spillover. And from the domestic animals, there is also a direct spillover to the human population. So this way, the disease surge, which is taking place in the wild animals, is spreading into the domestic animals and the human population as well. So if we are able to detect this, that is forecast these incidents of diseases or zoonosis in the wild animals, contain them at that level through alert and response system, we can stop both the spillovers, that is the spillover into the domestic animals and spillover into the human population directly. And once the domestic animal spillover is also minimized, then the spillover from the domestic animals to the human will also be taken care of. And thereby the total human population being exposed to this emerging and emerging diseases will be contained to a great extent. Some of the infectious agents that have adapted to non-human hosts can jump to humans, but achieving only dead-end transmission. When I say dead-end transmission, it signifies that there will be no further spread from the host. The infections in animals that are transmitted to humans are zoonosis, and those transmitted from one vertebrate to another by an arthropod vector are called vector-borne diseases. And these two categories are largely forming the bulk of the emerging infectious diseases. Some of these infections include the Lassa hemorrhagic fever, the hantavirus pulmonary syndrome, and many more. So viruses in these groups have co-evolved with specific rodent species who have come in contact with humans increasingly as a result of the modern environmental and human behavioral pattern change. One of the emerging diseases that one would definitely like to discuss, that is HIV, which has so far infected more than 60 million people worldwide. And HIV/AIDS might never have emerged had it not been for the disruptions in economic and social infrastructure in the post-colonial sub-Saharan Africa. Increased travel, the movement of rural population into the urban areas, facing poverty over there, and a weakening family structure, that led to increased promiscuity and increased flesh trade. And all these led to the emergence of HIV/AIDS transmission. So understanding some more transmission patterns. The next one that I'm going to take up is the hantavirus pulmonary syndrome, or HPS. The first epidemic of it was detected in the southwestern region of the United States in 1993. It resulted from the population of deer mouse going for a boom. And this was caused by the climate-related and recurrent proliferation of rodent food sources. So the increased rodent populations and the eventual shortage of food drove the expanded deer mouse population into human homes and subsequently exposing the human population to virus-containing droppings of this deer mouse, causing this HPS. Another disease that falls in this category of emerging infections is the Nipah virus infection. Well, it owes its name to the village in Malaysia, that is Nipah, where it was first detected in 1998. But it illustrates the influence of human behavior and environmental perturbation on the newly emerging human infections. There, what was happening, the pigs were crammed in the pens, and these pens were located very near the fruit orchards, where the fruit bats were dislodged due to deforestation, and their droppings were containing the till then unknown paramyx viruses. The virus aerosolization caused infection of these pigs in the pens, and since they were overcrowded, it led to explosion of transmission. And ultimately, the pig handlers were also infected in the process. And that led to this Nipah virus infection. A very important disease regarding re-emerging diseases is the falciparum malaria. It was neglected for several decades, but is now among the most important re-emerging diseases globally. Years of effective use of DDT was able to control the malaria to great extent, but slowly DDT fell into disuse. And this was because of the side effects of DDT, and people were more and more not inclined to use it to stay away from its potentially harmful effects on both humans and wildlife. But just as DDT stopped being used, malaria started re-emerging. And the situation has been worsened by the development of drug resistance to drugs like mefloquine, chloroquine, and research efforts presently focus on the development of vaccines and newer drugs and re-establishing the public health infrastructure and measures that were time-tested and now reintroduced into the system, like the bed nets. Another important re-emerging infection is the tuberculosis, and one of the deadliest one too. The discovery of isoniazid and other drugs initially had tuberculosis mostly under control. But the re-emergence of tuberculosis has been remarkable, and this has been fueled to a large extent by the emergence of HIV/AIDS because of the immune suppression, and hence the increased risk of the latent mycobacterial tuberculosis infections to progress into active diseases and being transmitted to others being on the rise. Not only just tuberculosis, HIV, which causes immune suppression in many, over millions actually, globally, has been also the reason for increased vulnerability to a wide range of opportunistic infections, be it fungus, protozoa, virus. So now coming to the fact, as we were earlier also discussing, that traveling is one of the reasons that has led to increased risk. So how can the travelers reduce this risk from infectious diseases? They need to seek information as far before traveling as possible. See a travel medicine specialist, or at least a medical health specialist who is familiar with the place of travel, and that too at least 4 to 6 weeks beforehand. Why 4 to 6 weeks beforehand? This is because so that the person in concern has adequate time to take the necessary chemoprophylaxis or the immunization that may be needed. So whatever immunization or vaccines has been suggested or chemoprophylaxis, that needs to be taken. And if one develops any signs or symptoms of these infectious diseases, they need to contact their healthcare provider at the earliest. So today, this is till now, and we'll meet again with the next part and many more interesting discussions on community medicine. If you like the video, please do like, comment, share, and subscribe. Subscribing won't cost a pie, but it would definitely be a motivating and moral boosting for me. Thank you so much.